Hello friends, welcome to another video. In this video we are going to look into how to create our own gradient colors. Few weeks ago I posted a gradient color part 1. In this one we are going to more in depth and in detail about creating our own gradient color for each column in a matrix view. Before we go into the solution and the whole discussion about the gradient color, but first look at the problem what we want to solve here, and then the step-by-step how we're going to solve it. I use some external blog post to understand and then converted that into the DAX format and to brought it into the visualization here. So let's first look at the problem. So here what we have is a Power BI simple matrix visual. So what I have is a C1, C2, C3, 4 on category on x-axis, and then the year on the columns. And then I'm just using the count. I think it's a sum of count value on my, it's a sum value. And then what I did on this one is I just applied the conditional formatting using background color, and I gave the starting range lowest value. Again, the lowest value color I use is FADB, and the highest is this red one, DB3236, and that's what I did. And once I applied that, what the matrix visual looked at, 10 is of course the highest value, that becomes the darkest color, and 0 is the smallest value, and that becomes the lightest color. Now the problem, as I said, this is perfectly fine. The problem what we want to solve here is we want to the gradient color. This is the current application of the gradient color is across full matrix visual, but we want this gradient color to be applied on each column. So in this one, 2019, 10 is of course the red, the darkest, and the 1 is supposed to be the lightest, and in this one 3 would be the darkest and 0 will be the lightest, and in this one, so basically what we want to do is the range of our gradient color from the max to the min should apply within that column, not across the full matrix visual. Now there's a lot of text involved in there. I will try to explain each and everything, but before I go into how we're going to solve it, there was already somebody provided a solution mathematically how to do this, and I'm not an expert in that. I followed that mathematic calculation and try to apply in here in Power BI. So let's look at that, what that calculation look like. I will post the link of this particular topic in the video description as well, but here is a question. I have a small table of values like pumpkin, and then the count, and this is the darkest color and this is the lightest color, and then user want based on the value create the gradient color for each particular row. And so this is what he explained. I use the same colors in my example here as well. For example, pumpkin 345 has the strongest color, and apple 22, which is the weakest color. So because this is the lowest value, and the potato is in the middle though, which is 62. It only has a count value of 62, which means it will be quite weak on the color gradient. So basically the gradient should be based on the value on the scale. So this is what they're trying to solve. So I use when I read through this, and somebody has really explained this very well. So because it said the color is not linear nor countable, so from strictly physical point of view it makes little sense to do this. However, you can approximate color as being linear for your purpose. So here the user explained, and I'm not going into all this detail. I will put the description link to in the description of this video. But the way to calculate linear calculation is this is what the user explained. So he said the x is a count, the minus minimum divided by maximum dash minimum. And so basically this is your color. First part is your hex color. You break it down into the decimals. So for each 2 hex code, you break it down, you get the decimal number. So dB is 219, 32 is 50, and 36 is 54. Similarly, the strongest and the lightest color, break it down into decimals. So that's the first part we need to do. and then find the distance. So this is the formula how you basically take, so this is now red, this is green, this is blue RGB color, and then based on this formula you calculate the gradient color. Basically first you create the red, green, blue. So now after your red, green, blue is done, then you convert it back into the hex code, and then that becomes your color for the each row. Again, this formula is here, and I can actually, I did the similar thing in Excel as well, just to quickly show how does that look like, so that I can convert this into DAX formula as well. So here it is like max value 345, minimum value is 22, and the distance max in between is 323. So, and again, start and end, these are the colors. So this is the strongest color, this is the lightest color. So these are the values for each particular product or fruit or whatever it is. So this is the value. So the first was count minus min divided by difference. So count is 345 minus min, which is 22, and divided by the difference, which is 323. So this becomes 1, and similarly this is the calculation being done here. And now once we have this one, so what we are doing here is, so D5, which is our R color for the stronger one, sorry, this is the lightest color, so that is 219, and multiply this with this particular now ratio, the distance has been calculated. Factor or the distance calculated, then what you're doing is you're calculating RGB colors from the decimal. So the first part is take the lightest color, the R value of lightest color, and then multiply this with the factor. So in this case this is becomes 219 multiplied by 1, and then this one is multiplying the R color of the strongest color, which is 250, and that is 1 minus D5. And again, this formula is all explained in that the blog post which I will share in my link, but I just want to show here what we need to do here step by step. So basically first we calculate the R value, and this is E5 plus D5, this becomes the R decimal value. Same thing we did for the G, which is the next color, and then for the B. So RGB, now this becomes the color for the each row. So as you can see, for pumpkin, which is the highest value, the color turned out to be 29, 50, 54, which is the strongest color. And for the end one, I think I have these names written backwards. So for the apple, which has the smallest value, the color RGB coming out to be the 250, 290, and 219, which is I think this is the darkest and this is the lightest. So now we have our, so between these top value and the bottom value, the max and minimum, so these are the further gradient, the RGB colors get calculated based on the distance, which is in the column D. So now once we have this RGB, then we will convert it back into the hex color, and then that will get used on the conditional formatting. So it means what we need to do is now when we know this formula, what we need to do is we need to take our RGB our hex color, convert into RGB, and for the each part of the hex color, which is 3 parts, like two characters, and get the decimal value of it, apply this calculation on top of that, and get the RGB values, decimal values, and then convert it back into the hex. To do so, I followed another post how to convert hex value into decimal and decimal to hex from Phil Seamark. He does great job, and I used his blog post to calculate hex to decimal and decimal to hex. Let me actually quickly show that blog post as well, and I will put the link of that blog post into my video description as well. So let's have a quick look at his blog post just to see how he has done that. Okay, so here is blog post from Phil Seamark. Again, I will put the link of this into my video description. So first is hexadecimal. That's what we are interested into using in our solution. So here he did only for like if the hex code is FF, this is the way to generate it back to decimal. And similarly, then he has there are more functions there, but we are interested in hex to decimal and decimal to hex. So here is again using this as a decimal value and then converted it to back into hex. So but he is shown here is like a one part of the hex code, since we have the hex color code of made of three, basically it's three letters, which is each part is two RGB, and then we are going to use these formulas and break our hex color into the decimal colors to get into the each section RGB. So how are we going to do that? So let's look into Power BI now, how I did that, and then go from there into the full solution to make it work. So here I used Filthy Mark's solution. He basically did for one hex code, but what we need to do is we need to break each hex color into individual pieces and then convert in decimal. So I created a DAX table, a calculated table here through DAX. So what I'm saying, okay, this is my max value color and this is my min value color. This can be stored somewhere else as well. So this is the darkest to the lightest. So what I'm trying to do here is I'm going to quickly walk through this maximum color length. So I'm making sure how many portions are of this particular hex code. Of course, these are three. And then this is the part where I'm generating a series. So what I'm doing is I'm creating a table, 1, 2, max color length, which will be 3. So there is a table generated series. I have a video generated series as well, which you guys can check out. And what I did is created a table, and then on that table I added the column. So I took the portion of DB3236. So at this point of time I have a table with 3 rows, and that is DB3236. So this is what that part is. Now once I have the 3 rows, I took those 3 rows and iterate over those 3 rows, and as you can see, this is max color, which is a table at this point of time with 3 rows. And then I took that color and then you take each hex code in that row of 3 rows and then convert it into the decimal. So this part of converting the decimal is same as what Filthy Mark solution. So this code is from him, that's what I'm using. So going through the each hexadecimal code or portion of hexadecimal code, because these are 3 rows, and then we're converting it to decimal. Similarly, this I did for the darkest color and then the lightest color. The same logic get applied, and then I natural join those two together. So the reason why we're doing natural join, so what I have is 3 rows of each table, 1, 2, 3, and then the hex color and the decimal color. And similar for the the darkest and the lightest color. When I natural join, so it becomes one table with the 3 rows with all the values in it. So let's take a look at that. How does the table look like? So this is the color table now look like. So value is that generate series 1, 2, 3. So max color hex, as you can see, that color is broken down into DB 32 and 36, 3 rows, and this is the decimal part of this. And similarly, the minimum color FA DB DB, we have 250, 219, and 219. So now we have this color broken down. Our hex color is broken down into the decimal in each section of RGB. Why we need that? Again, quickly go back to the Excel sheet which I used. So we able to achieve basically this at this point of time. So we need this to calculate the distance and the factor and everything, to calculate RGB for the each product. So once we have that, what we need to do is we need to regenerate these RGB columns and then convert it back into the hexadecimal. So let's look at what does a DAX code look like for that. All right, so here I have a gradient color measure I already wrote. Instead of doing it while during this video would have been taking longer, so I just already did it. So basically sum is just a simple sum, and then min and the max value which we created. So let me show you guys what those are. Sum is just a simple sum table count, and the min is so we took the minimum value across the whole table, so which is all, that's why we use all. So whatever the minimum value is, and the max value is again the sum max x across all the table. Because again, why we are doing this, I keep on bringing back this Excel file. So we calculate 3, 4, 5, and 22. That is what min x and max x will give us. And then we simply have the difference, which is 323 would be, I'm not sure if I did a measure or, oh yeah, there's a min max difference measure, which will max minus min will give us the difference. So now in a gradient color, so I stored the color table in the color table which we created in a variable, and so this is val the another variable is sum minus min divided by min max difference. So again, why we are doing this is part of the formula. So now what I'm doing is I'm adding a column on the color table, and of course calling it decimal. So basically what I'm doing is I am now calculating RGB colors for the each row in the color table. If you remember, our color table has 3 rows, one for R, one for G, one for B, which we created after taking the part of the hex code, color code. So now what this will give us a table, color table, which has the formula applied, and what does this means is this gives us the factor on our if we go back again to Excel sheet, so we got this color count minus min divided by difference, so that's the factor. So let me actually make it a little bit smaller here, so next to each other. And then this one integer or underscore val, so val variable multiplied by max color decimal, so that's the max color decimal, the min color decimal. So this is these two calculations, E5 and F5, and then finally what we need is we're interested in this number 219, so that's why this plus is happening here. So basically in the color table I am adding the decimal based on that calculation. So once that is done, this is the part of converting decimal to hex. Again, this part is from Phil C. Mark's post, where he has explained everything how to do that. So the only reason he has done on the one hex code, we need to iterate over each row because our table has 3 rows, and then we are on the decimal table which we have created here, and we're going through the each bracket and converting our decimal value, which is coming from this formula, converting it back into hex code. And this is the formula from Phil C. Mark, how to convert decimal to hex. So once this is done, now our hex table contains 3 rows with the decimal converted into the hex code. And then with the CONCATENATEX, what we're doing is we are taking all the rows and creating it as a string, as an hexadecimal code. So let me show you what this output look like. So here on page 1 I already have it. I shown all the measures here. Just quickly walk through what these are and what we got here. So let me make it a little bit bigger. Okay, so this is again the food, the table, and then what we have the max value. Of course 345 is the max and the min is 22, and that is the difference. And now this is the gradient color. As you can see, the maximum value 345 got the darkest color, and the end color, and the banana, which is on the lowest one, got the a starting color or the lightest color. And these are the variation between all the colors. Now I applied this gradient color on my sum as part of the background color. In this particular example, because we don't have the columns on the top, because this was a sample data set, this does not make much of a difference. I could have used the internal gradient color as well, but I have another example which I showed you guys here. We have a C1, C2, C3, C4 on the rows, and then 2019 the years on the column. So this is what the out of the box is, and this is data coming from table 2. Just quickly show you what the table 2 would look like. That's just the categories and the year and the value column. So I created the same gradient color in here as well, the same formula. Again, this is called the gradient color V1 because it's a different measure. So Now I applied the gradient color on this particular visual, now matrix visual with the rows and columns, and here is what the final output looks like. So if you look side by side, this is where we applied our custom gradient color on the left hand side. As you can see, let me make it a little bit bigger. So as you can see, this when we applied our own gradient color, this is 10 is the highest darkest and 1 is the lightest in 2019. Similarly in 2020, 3 is the darkest and 0 is the lightest, and on 2021 3 is the darkest and this is the lightest. So basically now this is out of the box what the gradient color look like in the matrix visual, and this is how we created for each category. And so the gradient color is going from by rows for each column, not for the throughout the matrix visual. Again, this is a not very common thing, but we have used many functions here. We created a DAX table, we use a hex to decimal, we decimal to hex, generate series, add columns. So a lot of DAX functions being used, CONCATENATEX. End of the day, we basically took our start and end grid hex colors broken down into RGB and apply the factor or the distance between max and minimum values, and then converted it back into the hex code, and that's what we applied on the conditional formatting. Unusual thing, but that does not mean that this cannot be used in certain scenarios you might have. And on top of that, you might probably have learned few DAX tricks which you can probably use in some other areas. Let me know what you guys think about it. It took me a while to put this video together. There's a lot more things to when I developed this. Took me a bit time to get to the point where I am today explaining all this thing. Let me know what you guys think. Do subscribe my channel. Until next video, have a good day. Bye for now. Thanks for watching. Thank you.